This conference will now be recorded.
Hello everyone. Today we are starting a new chapter which is general principles and processes of isolation of elements, and this chapter is also sometimes we call it metallurgy. Okay, so first we'll see what are the different important terms that we'll be using frequently in this whole chapter, and then what are the different steps involved in metallurgy, and also some examples of ores and minerals of different metals and some related problems. Here the first term that we have, it is metallurgy. So metallurgy, it is not a simple process. It involves different steps, and it may be scientific steps, that is some chemical reactions will be involved, and there may be some technological processes also. And remember, all these processes mainly we are using, our purpose is to isolate metal from its ores. Okay, so this entire process we can call it in a single term, which is metallurgy. Now the question is, here it is mentioned isolation of the metal from its ores, but what is ores? That you have to know. So there are two terms, one is ores, another one is minerals. These two are very their meaning is very close to each other, but there is a difference. Okay, these two are not same. So what is the difference that we have to see? But among these two, first we have to know what is minerals. Okay, because this is a broader version. They are naturally occurring chemical substances in the earth crust. They contain metal, but it is not pure metal. They also contain some impurities. So metal associated with impurities naturally present in the earth crust, that will be called as minerals. But what is ores? It is observed that suppose there are different types of minerals of a particular metal. So suppose you have metal copper, and it has different mineral. Mineral number 1, mineral number 2, mineral number 3. Now it may happen that among these three, only in one there is amount of copper which is very large, but in 2 and 3 the amount of, that is percentage of copper, it is not so large. So out of many materials in which metal may be found, only a few are viable to be used as a source of that metal. So it is not that the metal will be found, because in all these three minerals copper is present, but that mineral we will be calling as ore, which can be used as a source of metal. That means copper percentage must be very good, and not copper, I mean to say any metal, its percentage should be such that its extraction, because see, in this extraction process it will involve so many technological and scientific process. That means it is costly, that is cost effective. So that is why we have to choose the minerals in such a way so that after isolation, the metal that we'll be isolating, the amount should be good. Otherwise there is no meaning of going through such that is so many different processes, that is all these technological process or chemical reactions, whatever it is, it must be cost effective. So that is why it is not that all the minerals you can use for extraction of metal. Only some minerals we can use for extraction purpose, and it must be profitable, cost effective. So that is the difference between ores and minerals. So all ores are basically minerals, but the reverse is not true. So here we have three minerals, but you cannot call all of them ores. Only one is ore, because you can extract copper from one only, which is cost effective and profitable. Fine. Here we have some examples. Copper glans, that is Cu2s sulfite, salt of copper, and hematite, which is oxide of iron. But when we are saying that is, we are saying any name of ore, and in the bracket the formula is given, that does not mean it is containing only Cu2s. Obviously there is some other impurities, but the main component is this one, so that is why it is mentioned in the bracket. Fine. So what is the difference between these two closely related terms? Naturally occurring substances of metal which is present in earth crust, we will call it minerals, and those minerals which can be used to obtain metal profitably, we will call only those minerals as ore. Okay, so obviously all the ores are actually minerals, okay, but all minerals are not ores. Remember this. Here we have some examples: bauxite and clay. See, bauxite main component Al2O3 XH2O and some obviously some impurities. So here bauxite is the it is containing mainly aluminium oxide. So we can extract aluminium from this oxide. Okay, and there is another mineral which is also containing aluminium, but we do not use clay for extraction of aluminium. That means now the process will not be profitable and cost effective. So clay and bauxite both are minerals of aluminium, but we cannot call the later one as ore. Ore is only bauxite because the extraction of aluminium from bauxite, it will be profitable, not from clay. And another important term which is GANGUE, it is pronounced as GAN. Okay, so these are the undesired materials, that is the impurities, that part of the ore which we do not want. So we have to remove this part. So this is GAN, this is undesired part, which is also present along with the metal in earth crust. So this is also present in the ore naturally, but we have to remove this part, and there is different processes for this purpose. Okay, so here we have seen some important terms. Now some principal ores of some particular important metals. So only those metals where applications of these metals are very high, we will be focusing only on those metals. Okay, so when it is aluminium, see, different types of ores are present. Mainly bauxite is used for extraction purpose. Then we have iron, hematite, magnetite, both are oxide, but this is mixed oxide, which is a mixture of FeO and Fe2O3, but this is purely Fe2O3. Siderite, iron pyrite, limonite. Okay, so why I have presented this table here? Because related to this you may get questions. So suppose there are some names will be given, name of the ores will be given, and it may be asked that which, that is a particular metal among these four ore names of ore, which is the name of a particular metal, maybe copper or aluminium. Okay, then we have zinc blend. This is mainly used for extraction purpose. Then calamine, which is carbonate ore of zinc, and zincite, ZNO. Another one is total 3. Then we have lead. Okay, so under lead here we have galena, which is mainly used. The first one that is mentioned, that is mostly used, PbSO4, PbCO3, carbonate or sulfate ore. Okay, then tin, that is SNO, that is oxide. Then we have silver. Under silver we have silver glands. So mostly you will see the sulfide ore and oxide ore and carbonate ore. These three ores are very common. Fine. Ag2S, Ag3, SbS3. So there is also presence of antimony. Then AgCl, though these are not mainly used, mainly silver glands, that is Ag2S is used. And under copper we have copper pyrites. Now this name is very interesting because here you have both the metals present together, copper as well as iron. Okay, then copper glands, just like silver glands. See, this is also sulfate, this is also cuprite. This is copper 1 salt, that is oxide. Then we have malachite. In malachite you have carbonate as well as hydroxide. In azurite also this is same, but here composition is slightly different. This is 2CuCO3 COH hold, but here we do not have any. Okay, so see, this type of problem we may have. It is asking the ore that contains both iron and copper, it will be which one? So copper pyrites we have just seen. See, it is containing both Cu and Fe. That means this will be the correct option. Okay, so if you are see this in this question, if you are confirm about this name, that is it is containing both copper and iron, then you are done, because rest of the three you don't have to check. Okay, because only one of these four options are correct. But what are the other ores? What are their components? Malachite and azurite. See, both are hydroxide and carbonate of copper. So these two are not correct option. And dolomite, it is actually carbonate salt of calcium and magnesium. Okay, here we do not have any copper or iron. So here correct option will be copper pyrites. In this slide, you will see some examples of that is list of ores, but these are based on anion. In the previous slide, you have seen which is mainly based on the metal. That is, if it is copper, under copper, how many different varieties are there? Under iron, how many different varieties are there? But now we have fixed the anion. Okay, sulfide ore. That means it must contain sulfide iron is 2 minus. So under sulfide ore, see how many different metals we have: lead, mercury, zinc, copper, copper iron mixture, then only copper, silver, CuAg and Ag antimony. Then halide ore. That means it may contain Cl minus, it may contain F minus, halide iron X minus in general if we say. Here we have some S block metal chloride, then calcium fluoride, Na3LF6, AgCl, KCl, MgCl2, 6H2. Then the third table, this is containing nitrate, though nitrates are not mostly used. But here these two examples are very important, KNO3 and ANO3. So this is called Indian saltpeter, the second one Chile saltpeter. Some more anions. Oxide ore. Now this is also very common, that is O2 minus, and see almost all the metals are present here, right, from which we can extract metals. Then carbonate ore, so it will contain carbonate ion, and here we have S block metals, D block, and also we have P. Then sulfate ore. Sulfate ore means it will be containing SO4 2 minus. Okay, calcium, magnesium, lead, barium. Mostly here we have S block metals. Fine, we do not have any D block metals. So these are the list of ores based on anion. So the problem. Here we have to match list 1 with list 2. In list 1 we have name of different metals. In list 2 we have ores. So we have to match them. Okay, we have aluminium, iron, copper, Zn. Okay, so see here we have all these examples. Siderite, which is basically FeCO3. That means one is matching with B. Then calamine, it is zinc carbonate. That means 2 is matching with D. Now see here options, if we observe carefully, if suppose all these names, if you are not able to remember here, if you are sure about the first one, that is FeCO3 is actually siderite. That means 1 is matching with B. So just if you are confirm about this, you can easily choose which option is correct, because see option 1 B3, B2, B1, B4. So only in option 3 you have B1. So without considering rest of the 3, if you are confirmed that siderite is containing iron, then also you can answer the question. Fine. Then 2 is D. So see here D is matching with 2, and copper is basically malachite, because in malachite we have carbonate of copper, hydroxide of copper, and in kaolinite we have here aluminium mainly, okay, because we are extracting metal. So silicon, it is not considered as metal, so we will here focus on aluminium. So 3 is matching with A and C is 4. So your correct option will be option 3. Any doubt? Now we know what is metallurgy, that is the entire scientific and technological process, but there are some types of metallurgy. Fine. So sometimes it is the case that we will extract the metal from the ore mainly using by heat energy. Though whenever we are saying metallurgy, it is contained in several steps. It is not very simple process. Okay, but we have to see mainly what type of energy, what type of process we are using. Based on that, here we have this classification. So when we are using heat energy, because the word pyro, it is related to heat. So it must be the case where heat energy is used. So when extracting metal, we are using heat energy, then it will be called as pyrometallurgy. But as we have already seen that metallurgy is containing different steps. So here the steps that are involved, the names are calcination, roasting, reduction, etc. So this is not the end, it is just 3 examples. Fine, we will consider all of this separately, but all these are under pyrometallurgy, because in all these processes you have to provide a very high temperature. Now pyrometallurgy is used for what type of metals? We will use pyrometallurgy for less reactive metals. Now less reactive metals means it is mostly D and P block metals, because S block metals are very active in nature. So in that case you will see high temperature is not required. But when it is less reactive metals, high temperature will be required. Okay. Then we have hydrometallurgy. So the word hydro, obviously it is related to water. So this is wet metallurgy process, and here we for which metals we use this? Silver, gold. Ion exchange metallurgy. Now this metallurgy we will not discuss in this chapter, because it is mainly for those elements which are after uranium. Okay, that is from A block, actinides. So only for transuranic elements. Transuranic, the term means all those elements after uranium. That is atomic number after uranium. That is atomic number must be greater than uranium. All these will be called as transuranic elements. So they are also metal. So that is why for them ion exchange metallurgy is used. Just remember this thing, that ion exchange metallurgy, it is used for A block metals after uranium. Okay, though this will not be discussed in this chapter. And electrical metallurgy. Now electrical metallurgy, it is mainly used for highly active metals. So see in the first example what you have seen, it is mainly D and P block metals. But for electrical metallurgy, it will be mainly the S block metals, because now it is mentioned here highly electropositive. Highly electropositive metals, obviously S block metals, that is group 1, group 2. So mainly it is S block, and from P block we have one example, which is aluminium. So in this process, what we mainly use? The process electrolysis is mainly used. Electrolysis process details we have already discussed in electrochemistry chapter, so you have some idea about it. Okay, so electrolysis will be done on the fused salt, that is without any water part present, and hydrosmithing. So this method is used for highly electropositive metal. So here we have mainly 4 types: pyro, hydro, ion exchange, electric. Now in metallurgy, what are the different steps involved? Because we have already seen it is not very simple process. It is containing several deep steps. Okay, so this is very intricate process. The entire scientific technological process used for isolation of metal from its ore, this is known as metallurgy. That is the definition. Now the extraction and isolation of elements from its combined form, it involves different types of principles of chemistry. Now different principles means, suppose sometimes it may be that you are using some reduction method or some oxidation method. Sometimes we even form some complex, okay, that is metal ligand complex. Then we can do some electrolysis method. So that is why it is mentioned different types of principles on the basis of which we will do these steps. But however, some general principles are common to all the extraction processes of metal. So there are some steps out of these different steps which are very commonly used. Okay, so these methods, they have particular name and they are very common. And ore rarely contains only a desired substance. So it is always associated with impurity, undesired material. Fine. It is rare that it is very pure. That is not possible because it is naturally present in the earth crust. So obviously it will be containing some impurities. As it is mostly contaminated with earthly or undesired materials, and all these impurities, they are known as gangue. Now the three main steps that are involved in metallurgy. Okay, number one method is concentration of the ore. Now concentration of the ore, it is nothing but purification of the ore. So suppose you have any copper ore. So in that copper ore, it is there is presence of sulfite, but there is also presence of some undesired material, suppose XYZ. Okay, so what we do in the first step, we try to concentrate the mixture. That means we will do some processes by which we can minimize the amount of XYZ and we can maximize the amount of desired material. Okay, so this is one kind of purification of the ore. But by purification, do not think that in this step you will get pure copper. No, you will not get pure copper. You will get copper sulfide only, which is the main component, but it will be in higher amount. So suppose when you have not started the process, the amount of CuS, it is only 50%, and after concentration of the ore, because you are increasing the concentration, now the composition is changed to 70%. Just arbitrarily I am giving you some example. So this is the method of concentration. Now when it is we have already increased the percentage by decreasing the undesired material, the next step that we can do, remember, the next step you can do only after you have already done the first step. You cannot start the process from the second. It is second. You can do it only after the first. So in the second method, what we do, now we isolate the metal from its concentrated ore. So when I'm saying that it is 50%, it is 70%, still it is copper sulfide. But suppose now in the second step, what you are doing, you are now isolating the metal only. That means now you will get the metal. So this is the first method. This is the second method. Okay. So this is isolated metal from its concentrated ore. Okay. Now this is not the end of process, because still it will contain some impurities. Okay. That is, you can say, gangue. So this undesired part we have to further remove. So the third process which we will do after the second process, that is called purification of the metal or refining of the metal. That means we will remove the last traces of impurities. So suppose now the percentage is 95%, and after purification it is almost 99.9%. So this is purification also. But the first process is purification of the ore. Try to understand the difference. But this third step, this is purification of the metal. Okay. So finally metal is extracted after the third step, and it is in very pure form. So these are the main steps. But remember, under each of these three types, you will have different methods. So suppose when we are saying that in the last step we are purifying the metal, under this purification there are so many different principles involved. So in some case it may be you are doing the purification by crystallization. In some case you are doing the purification by column chromatography. In some case you are doing electrolysis. So under purification, there are different methods based on different principles are present. Okay. And similarly, when we are saying concentration, there are also different methods. So each of these methods under these three broad categories we will discuss. So the first step is concentration of ores. So concentration of ores, we will see some detailed features of this process. The ores that we have obtained from the earth, obviously it will contain large quantities of foreign matter, that means which are not required. So the process of removal of this unwanted material from the ore, that is known as concentration. You can also call it dressing or benefaction. This separation can often be achieved by physical means, okay, because can often be achieved. It is not that always you can do so. Sometimes you can do so. And when you can do by physical method, when mineral and gangue generally occur as separate solid phases. So mineral you can also call it ore, because only those minerals we use which is basically containing a very high percentage of the metal, salt or oxide or carbonate, whatever it is, and those minerals will be called ore. So you will see sometimes it will be mentioned as mineral or ore, but that is actually the same thing, right? So when the gangue, that is a foreign matter, it is already present as separate solid phase, that is visually you can easily understand which part is not desired. So in that case, by physical means you can do the separation. Before proceeding for concentration, ores are graded, crushed to reasonable size, because when it is already obtained naturally from earth crust, it may be present is very large chunk form, or which are not very easy to handle. So that is why for better handling we have to grade them, crush them, so that the size is now reasonable. Fine. It involves several steps depending upon the differences in physical properties of the compound of the metal present. So physical properties of the compound of metal, because the metal may be present in the form of carbonate salt or sulfate salt or sulfide, oxide, different types. Now different types, when we are saying, obviously their physical properties will also be different, and not just the physical properties of the ore, also the physical properties of the undesired particle. Okay, so depending on by physical properties, suppose melting point or boiling point you can consider, or you can consider solubility. So if that is melting point of gangue and the actual metal salt, if their melting point or boiling point difference is very high, obviously we can utilize this temperature, so that one will be in melted form, another will be in solid form, so you can separate it. So this is just one example how by applying a difference in physical properties of the desired part and the undesired part we can remove the foreign part. Okay, the type of the metal, the available facilities, that is also very important. Though maybe different principles are there, but when we are actually doing this, okay, practical, when we are doing this, it is not necessary that always all the facilities will be available. So depending on the available facilities also, and considering the environmental factors, that is we have to choose those processes which are not creating very high amount of pollution in the environment. Okay, so all these points we have to keep it in mind. So the first method under concentration of ore, see, this is number one. So this is the simplest method because it is hand picking. In this process, the impurities, that is the foreign part, will be removed by just simply picking with hands. And obviously you can understand, as it is done manually, so the impurities must be large in size and heavy impurities, otherwise how you will do it manually. Okay, so only when the ore is containing this gangue or andesite or impurities which are very large in size or rocky type of nature or pellets, okay, which are easily, that is visually you can easily understand that it is not desert. In that case, hand picking is possible. Okay, so this is the first method of concentration of ores. The second method, hydraulic washing. Hydraulic washing, it will obviously related to some water part. That is, it is hydraulic washing. So in this process, what we will utilize? We will utilize the difference in gravity of the particles of gangue and the ore. So gangue is not desert, but ore is desert. So what we will do? And their particles are different in size. So difference in gravity, not just size. Difference in gravity means one will be heavy, another will not be heavy. So that is why on the basis of gravity, you can separate them. So one of them must be very high weight compared to the other one. Then only you can do this process. So in this process, what we do? The ore is fed into the tank from the top and water is allowed with high pressure from the bottom of the tank. So here, see, in this tank, you have taken the ore which is containing the impurity. And this is falling from here. And you are supplying water flow with a very high pressure. So as the particles that are falling here, there is difference in gravities. So some particles are lighter, some particles are heavier. Here the deep blue part that you are seeing, that is actually the heavier part. So that is why they are in the lower portion. But this light blue part, that is the lighter part. So that is why they are on the top position. So water and lighter gangue particles, in this case the lighter part is gangue, mostly that is the case, but opposite may also be the case. Okay, so with this force of water, the lighter part that will be removed. Okay, water and lighter gangue particles, and ultimately the heavy particles will be remaining here. So lighter impurities which are adhered to the ore float over the water and can be removed, and the water particles, sorry, ore particles, they will be settling down at the bottom of the tank because they are heavy. Because of gravity, they will settle. And which type of salts are mainly used in this hydraulic washing? They are generally oxide, carbonate ores are concentrated by this method. For example, hematite, cerussite. Hematite is oxide of iron. Okay, so this is the second method. The third method, magnetic separation. Now when we are saying magnetic separation, that means there is desert part, there is undesert part. D is desert, U is undesert. So one of these material must be attracted to magnet, another one not attracted to magnet. So based on this principle, we can separate them. So only when the ore or the gangue is attracted towards magnetic field, then only you can apply this method, otherwise not. So in this method, what we do, the ore is passed through a belt, and this belt connected by two rotating wheel. So this is the two rotating wheel and this is the belt. Okay, now finely ground ore that we are supplying here, so they will be spread over this belt. Now one of these roller that you are seeing, that is magnetic in nature, not this one, the left hand side, that is magnetic in nature. Now the magnetic part that will be attached to this wheel, but the non-magnetic part, which is the yellow part, that will be removed. Okay, so once the ore is passed through the belt, the ore particles are attracted by the magnetic wheel and fall near to it. Okay, so it is falling near to the wheel, but it is not falling near to the. So in this particular example, we have considered the desert part is magnetic, undesert part is not magnetic, but reverse may also be the case, though mostly it is not so, because whenever there is any iron salt, then this method can be used because they are attracted towards magnet. Fine. So non-magnetic part, which is the undesert part, in this way they can be separated. The impurities which are non-magnetic, they will not be attracted by the magnetic field and they fall away from the magnetic field. See, they are falling away, the yellow part. Now, what type of materials you can separate by applying this? Rutile, which is titanium ore. This is magnetic in nature. It can be separated from chlorapatite. Chlorapatite is this one, chromite. So this is the end of the first example. So here rutile is mixed with this impurity. So you are removing this impurity because it is not magnetic in nature, but TiO2 is magnetic in nature. The next example, chromite. Chromite is iron ore, FeCrO2 2. Now this is magnetic in nature. So you can separate it from the non-magnetic gangue, which is siliceous in nature. That means it is containing silicon. Okay, so these are two examples which can be concentrated by applying this method. Is there any doubt? So we have seen three methods: hand picking, hydraulic washing, magnetic separation. Some more methods are also there. Up to this, any doubt? The next method, froth flotation process. Number 4. Now this is very common method, okay? This method extensively employed for the preliminary treatment of minerals, especially sulfides. So froth flotation process is mainly used for sulfide ore. The process, it is based on what principle? It is based on the principle of difference in weighting characteristic of the gangue and the ore. So gangue is the undesired part, ore is the desired part. Here gangue is weighted by water. It means it is soluble in water. But ore, that is weighted by oil. That means it is not soluble in water. It is soluble in some non-polar substance. So basically, this method is based on different solubility of the undesired part and the desired part. Okay, that is mentioned in this way. That is weighting characteristic. So obviously, we will use some water and oil. So what is done in this method? The crushed ore along with water, which is called slurry, it is taken in the flotation cell. And different types of substances are also added. And these different substances, they are together called additives. Now, what type of additives you will be using? That is dependent on the nature of ore. Okay, so we will see the names. And remember, in this process, we supply a current of air, which is blown under pressure. So how this mechanism is working, that we will see in the next slide. But before that, we have to know what are the different additives that we mix with the slurry. So the additives are called as frothers or froth stabilizer, collector, depressant. So we will see each of them one by one. Froth stabilizer. So from the name you can understand, these are added to stabilize the froth. So this is the first reason. Second reason is it is also used to enhance the non-weightability of the mineral particles. Okay, that means it decreases the solubility to water. That means it is increasing non-weightability. And examples are cresols and anion. And what type of compound will be actually used? That is dependent on the nature of ore. There is no hard and fast. So this is froth stabilizer. Then what is collector? Now collector, when we will see the definition, you will find some similarity with froth stabilizers, but these two are not same. A collector is a type of organic compound that selectively attaches to the surface of the mineral, or you can also say ore, and adds water repelling nature. So this is almost same thing as we have mentioned in the froth stabilizer, because here we are saying that we are enhancing the non-weightability. That means we are enhancing the water repelling nature, right? But there is some difference, though you are seeing some similarity, but there is some difference because it is stabilizing the froth also. But collector is not so. These are the examples. And what is depressant? Depressant used to separate two sulfide ores And how it is separating, helping in separation? By preventing the formation of froth by only one ore, not the other, and allow the other ore to be attached with the froth. So for example, NaCN is one of the examples of depressant which helps in the separation of mixture of sulfide, zinc sulfide and lead sulfide. So what it does, it selectively prevents Zn sulfide, zinc sulfide from coming to the froth because it can complex with ZnS, but it doesn't make any complex with PbS. So that is why it is allowing PbS to come with the froth. But what is the mechanism? If you are not seeing that, then you will not be able to understand how all these additives are actually working. In the next slide, we will actually see the process, how it is working. So this is the, as here it is mentioned, the name flotation cell. So this is the flotation cell. Here, first collectors and four stabilizers added to the slurry, that is water plus ore, and you are adding to it collector, four stabilizers, and after adding all this, now you are feeding this mixture through this tube. Okay, so in this mixture you have both hydrophobic material, that is which is not soluble in water, and also hydrophilic material, that means which has attraction for water, that means it is soluble. So both types of material present. Now here we are using a rotating paddle which will agitate the mixture. It will start the mixture, as a result air will be drawn. Okay, that is the purpose of using this agitator. So when water will be drawn, there will be some formation of froth. Okay, and that is bubbles like material will be formed which carries the mineral particle. Because see, if we enlarge this part, this is the bubble, air bubble, and all these are hydrophobic part. Because the hydrophilic part, that will be attracted to water. Okay, so that is why these are not attracted to water, they are on the surface of this air bubble. So basically this is the froth. See here, this part is deep blue, but this part is light blue. So the light blue part is actually the froth, which is lighter compared to the mixture. So they will be on the surface, on the top, and they are containing all the hydrophobic material. And this hydrophobic material now from the upper part, it is collected. So this is collected froth. And in the lower part, see, only this yellow colored material you can see here. That means hydrophilic materials are left here. So ultimately, you are separating the hydrophobic material and also the hydrophilic material. And see here, this enlarged version that you are seeing, this is basically the hydrophobic material carried to the surface by the bubbles of air, and it forms a froth. Okay, and this froth is collected here and ultimately separated. So this hydrophobic material, this is mainly containing our required part, that is the desert part, and the hydrophilic, that is containing the impurities. So froth is formed which carries the mineral particles, that is the desert part. This is lighter compared to the hydrophilic part, and skimmed off. So it is then dried for recovery of the ore particle. Now sometimes it is possible to separate two sulfide ores by adjusting proportion of oil to water by using